Okay, what we're looking at is commonly known now as the Willamette meteorite. Somewhere between 15 and a half, 14 tons. It's a huge thing. And it's on exhibit at the American Museum of Natural History in New York. Yes, that one. And it has a strange appearance to it. There are a few descriptive weird words to describe this immolated or creviced surface that's all upon this thing. Makes it look outstanding somewhat. It's not just smoothed off like a river rock. It's had all this gougedness to it and little holes pop through it and things. And it's huge. It's worth 7 trucks worth of weight. If you were to squish them in a knot in a compactor, you couldn't get there. It'd still be 4 or 5 times this size. You have to melt it down and form it into something that would be along this size and shape. You might be able to get a little smaller because of the crevicing in this, but you understand the idea I'm showing you here. On its body, on parts of it, are extreme dents, like in the bottom left-hand corner and around that little cup that's there. And it almost looks hammered or worked. But also, they say that if you have a huge amount of metal at a molten state, slinging it, and the internal part was not quite as hot as the outside, i.e. red hot versus orange sparkling welder, that a crackling of the surface might do this due to wind blowing onto it, and therefore it would leave a rippled surface across it from the massive amount, well, like your cheek would do in the wind when you're falling, but let's say it was happening at like 30,000 feet per second, something along that line. You can only fall at a terminal velocity. This thing came in with kinetic punch, and it was trying, physically you think it's trying to put the brakes on, but the atmosphere itself is kind of like you diving into water and how it slows you down real quick. And it slows these things down, and that rapid deceleration through all of a sudden some atmosphere they haven't ever seen in a long time causes it to just rapidly heat up. And that's why you see a shooting star come in, which is usually about the size of this plate down here, and as it comes in, and very little's left. But when there's something that's about the size of this plate, if it's made just right and stuff, you'll end up getting a chunk that hit the ground. Might be a golf ball, might even get a little larger, might be a little smaller. And the rest of it is little bitty pieces that still fall to the ground, whether it's in dust or anything else. So it's not like we don't end up getting it. Weird thing about stuff like this, it's hard to fathom this idea in its reality, but this was formed inside of a sun a long time ago, at least 4.2 billion years ago, 4.5, inside of a sun that had already gone through its whole life, not like ours, but had come to the end. Somewhere near our galaxy, in the same area as ourselves. Somewhere near to us that if we were there now at our current state, would have seen the supernova very readily, and in its explosion and effects ejected this out, floating through space, and like a bug floating around in the air, and you driving along in your car, smack, re-ran into this. A lot of times people think that, we're just sitting here, Earth isn't moving. We're just sitting here and things come flying in. Something came flying in. It's not the effect. We are moving through stuff, swirling on an arm, a little cosmic arm over here one of many swirls that are part of our galaxy that's going round and around, and we're going round and around too. If something up ahead of you, like in NASCAR, blows up, you're going to keep going on. Boy, you better hope you don't hit that. Funny thing they say, if you're far enough back, you almost want to aim at it, because that car is not going to be there. Even though it wrecks and it's right there, it's not going to be there in a minute. And he's probably going to slide down on the track or up into the wall, and you make a choice at that point. If you try to go towards it, it's almost better to just go straight forward and do a slight veer, because he is going to be moving. That's way off of this though, but hey, they're made out of the same iron that comes from things like this. Regardless, let's get back onto this topic here. So, when did this happen? You know, because we find things like this, but we're trying to find currently, me as a group and a lot of others as a group, is something that's real near and dear to us, and it means something. I mean, we found the dinosaur impacts, and there's like volcanoes that cause certain things and so on, but we're looking at during our lifetime and what's happened to us. You know, we can segregate that part at 150,000 years and say try to concentrate on this a little bit more sooner and see if we can find mankind's, you know, between 1,000,000 years in here for sure. But let's try to focus and have groups that focus. And anytime I find it's found that's focused, that group that knows what the hell they're talking about focuses. But not just that group, because somebody else has to be there to focus, and they shouldn't be subjected to the other group's bullshit until they focus. Just set that aside. What we're looking for is something that tries to show this younger dryas impact, and it seems to be hard to find. And people talk about, well, it was up to 2 miles thick of that ice shelf that's there, and the Cordovan ice shelf and so on. That's a couple that were across North America, and then there's the one of Europe, you know, and runs around, and there's conspicuously missing a good gouge off of the Soviet Union, Ukraine over there. And if we quit looking at it like that, and we stick the Ukraine together and look at it from the Alaska point of view, and you can see the connection in the little Aleutian Islands that come out there, and then you see that, oh, okay, that corridor was really at the last glacial ice age fairly much open more bit there, right? And we weren't waiting for this thing that they talked about in that state, but that's in another video about peopling of the Americas. What we've been looking for is something that causes that younger dryas event, that hiccup. I did a video on it recently that shows you this wham, this big hiccup. Even if you say that, okay, we're down here, and then we go up, and then we go down, and then we go up, and it's like tick-tock, like a sine wave, and then all of a sudden you get this little jag, and you're like, well, what was that? Anybody that's a radio astronomy would be like, back that up. And they would be able to back up right through something, and couldn't find it, then they would get trajectory and try to find out where that thing was moving from they were getting a signal from. Although there are theories that have turned around and taken this to mean not so much. But sometimes it might mean a lot more than you would think. I'm beating around the bush a little bit, ain't I? We've been trying to find a meteorite that has something to do with this event. And right here in the Natural Museum is this marker of this event. If we look at this Willamette meteorite, was officially named Willamette, and originally known as Tamanawas by the Clackamas Chinooks, Native American tribe, and they thought that this thing had fallen from the sky, and of course sky and God and everything, and so it was marrying heaven and earth, and it had caused water or something, and that's a good thing. And so they, you know, they kind of not worshipped it in any way, but it was a thing. And they had known that it came from heaven. They had put two together, and at least in their folklore or whatever, kept it all along as a known thing. Okay? And they're saying this, here goes Spidey sense. They're saying that this thing, that there was no impact crater. No impact crater. Impact crater, what's it look like? Thought. Here's an impact crater. There's a bunch of little ones there, and there sure is a big one down there towards the bottom of that, right? Impact crater. There was no impact crater at the discovery site. Well, you wouldn't think, you know, some people think that pow, and then you'd be just sitting there, but that rarely, if any, ever happens. It hits at slight angles and pow, and ejects off of it. Too much speed and power is put into it, and it blows this thing to bits. Even though it's holding together and the outer skin is real moist, you take and go wham with a hammer at that time, and a piece of metal goes bleh. Well, you do it with a piece of metal striking the earth with that kinetic energy, and it shatters into pieces and slings pieces. There's no impact crater at the discovery site. Researchers believe that the meteorite landed in what it was now Canada or Montana and was transported as a glacial erratic. Glacial erratics are whenever large rocks somehow get moved along with or inside of giant icebergs in part of glaciers. But this would be a little bit different. This would be a 14, 15 ton object, and they say the rotting out of that would have made it even more than 15 and a half easily, but the, you know, dimpled area of it there, creviced area, gouged out area of it there would have made the thing closer to 20. And no telling what it came in at. And if it was just a piece of what came in. But let's continue. It was transported as a glacial erratic after a big thing happened in the Willamette Valley, and the Willamette Valley down through here during the Missoula floods. And they are willing to believe that this whole valley channel here, a huge thing that's kilometers, miles wide, going down through this valley here, just ate through all of the land, scouring it, and leaving behind these giant boulders, which I wish it had them here, but it's just showing Willamette Valley. If you go to it and it talks about the farms of Willamette Valley or whatever, so it's not going to talk about, look at this glacier problem. It's not. It doesn't do that. Willamette Valley, it's not on their brochure, right? But it did this during the Missoula floods. Now the Missoula floods were cataclysmic glacial lake outburst floods that swept periodically, across eastern Washington and down the Columbia River Gorge at the end of the last ice age. These events have been researched since the 1920s. Let me get down on it here a little bit. Periodic sudden ruptures of the ice dam of the giant glacier that's up there, right? This happens at the end of the last ice age, 13,000 years ago. Although in the dating on the object it says 15-ish. And I wonder how they would possibly date that, because the idea is just that it came down like a skipping rock and ended up on the glacier, and then whenever this busting forth of the Great Missoula floods happened, it got washed all the way down Willamette Valley to where they found it at. Are you with me? Okay. And so there's been a big problem after that. It was long been held sacred by indigenous people of the Willamette Valley, including the federally recognized Confederate tribes of the Grand Ronde community of Oregon. A meteorite is on display in the Natural History Museum in New York City, or American Museum of Natural History. I'm sorry, it's a different thing. Which acquired it in 1906, having been estimated at 40 million people over the years, having been seen by 40 million people. It's like McDonald's. It is among the most famous meteorites. In 2005, the GTRE sued the meteorite to be returned to their control, ultimately reaching on an agreement that gave the tribes access to the meteorite while allowing the museum to keep it as long as they are exhibiting it. Now that's a strange thing, because in the other thing that I hear about it, they tried to start giving it back. They wanted to give it back, and they were basically like, what? Nah, I mean, that's a great place to keep it. It's not like we felt it was our kingpin or the pin of anything. And then even later, one little chunk that they found that they knew was related to it, that they had found, they tried to make this big ending ceremony and give it back to them. And this has got to be a sad moment, kind of, where they're giving a rock back to them, and things that people go, why don't you just give all America, it's just yeah. So it's about 32,000 pounds, 15,000 kilograms. It's classified as a Type 3 iron meteorite, being composed over 91% raw iron and 7.6 nickel, traces of cobalt and phosphorus. And this is getting to that exact weird amount that you would put into an ancient sword of old that had those special properties to it too. And it's just got this little extra stuff into it, folding and carbonizing this thing effectively, while forming a sword, would make an incredible sword. Let's just say that. Let's just leave that alone right now. So, where this happened, impact, placement, and erosion. And so here are these great Missoula floods that came down through this area here, off of the glacier. And I wish there was a picture real quick here of a glacier and where it came down to. This is not that it's its extent. And whenever it let loose, it basically carved out this whole valley and then burped out over and went out in here. There's some people believe that it caught the Colorado running down through here and did a lot of its thing, and ended up forming and or extrapolating very much more and adding to the thing that we know as the Grand Canyon today and other type of things. But that's a different effect altogether. And isn't it funny in this picture? Let's just take a look at this. Isn't it funny in this picture? There is this crescent shape right here. We can see kind of, but the only problem with it being a crater or anything from some big impact of old or whatever is that the mountains are all grown up here. But then there's a circular pattern that I'm sitting in the middle of right now. And there's another one over here. And there's another one over here that all this water's going around too. And effectively, they're telling us that what happened is this up here, like up here, this is like a lake in the icebergs in the middle of the glacier. So effectively is like a little lake. Now they try to minimize the thought of this idea somehow in its wording, for they call it ponding. Yeah, they call it ponding. In a land where something as big as my blue dot here is the biggest lake that there is, they call something like this right here ponding. This Lake Missoula is supposed to be basically a huge area in here, and there was supposedly maybe a couple of melting ponds in the middle, somehow created from, I don't know, keep that in mind, in a couple of places across here. But their idea is that they were doing that, and then they were cutting loose bigger valleys, like things running through here. And then the way I understand it, all of a sudden this thing got and let loose and went down and just gouged the crap out of things, and then stopped. and then kind of refroze a little bit, but they still had a little ponding going on, and it would fill back up and then and let loose again. And that somehow in their findings they find that it did it once and it did it again and did it again and multiple times. And that's okay too, as long as we get an understanding. But the idea that this thing would have been somewhere up here and traveled all the way down a meandering path and ended up about here is quite telling, conspicuous, and in fact they themselves tell you that it happened with these associated events. The only problem between that and the actual fact of the younger dryas being able to be totally correlated to things like this happening is there's no evidence. And we're looking at it right there in the Missoula floods. Is it possible that whenever it came in and popped right here, that it made a giant crater in the ice, flash melting it as it exploded, and then popped out like a welding spark and ended up down here? Or let's say it ended up here, but when the flood happens, it went blah, blah, and then it ended up there. Is that a possibility? Because there's no way of dating that thing. The way that I understand it, there's not really any true validity way of dating it, but then they're dating it to have been brought down as a glacial erratic at the time of these great floods. And that it had just been sitting there on the glacier or something, and whenever it let loose, it got carried along with all these big boulders and all these other glacial erratics that, like Randall Carlson has been showing us. Get a drink here. So the thing and the problem that they have is that the younger boundus dryas event, blah blah blah, is showing up to range 1400 years worth of time and not really looking like it pinpoints a place in time. Well, they're saying 13,000 on this, but it got there at that dot with my blue thing at roughly, this right there in the threshold of the time we're talking about, 10:05 or so, right? Its final destination. And hey, I mean, they could theorize it could have been in the first one, it got pushed to here, but somehow in the second it caught that because it was a bigger one. If they, whatever this lays out to be, and come out and ended up here, or whatever, it regrew parts in ice, and then whenever this washed out, it just picked up that whole chunk and slung it down here, and it ended up there. There's a lot of scenarios that go along with this idea of what had happened. And if you say there's no evidence, we have the Hiawatha crater now, which is about the size of my blue spot. No, it's a little smaller than that. It's maybe about the size. It's even smaller than that right there. And see that little round circle I'm pointing at right there that it won't focus on? It's only about that size. But you'd be amazed at what a kinetic energy punch of something coming in twice that size, melting up and zots, hitting the earth that, say, I'm up in here somewhere. Now, we all agree that the ice after this point melted and the glaciers kept coming down, and literally by coming down, what you mean is this spot right here is moving down slowly over the ground, and it keeps going. And our glaciers are still moving. The leading edge is receding away, but they're still moving. A mile from that front edge that's melting away, it is still gouging the ground in this slow movement of just pounding tons of weight on top of little gravelly bits and just grinding away the surface, somewhat filling in holes and taking down bumps like God's sandpaper, and you with me? And so if there was anything that made it through 2 miles of ice, and you'd think if something come in hot and it hit ice, that'd be that real drastic temperature change, and even if pieces made it in there, there'd be this pop that went on, and that might have made the surface of that look like that in some way too. It's popcorn effect. After the kernel hit the ground, sizzling, and it popped. Well, it didn't poof like popcorn. It looks like it may have been gouged out. And they say this acidity erosion effect happened in through it due to its own processes, and left that where it eat away the parts that weren't made of the metal and just right, if you will, more so than the others. And that's over a couple of thousand years, and it would still happen with this acid rainy kind of almost effect on it because of it. The rain on it would moisturize and pool in these spots and dents, and then because of their erosion and stuff, it would eat more into it, wash out, make it anew, form it again, and eat it again, so on. Anyhow, that's how those dents were made, much more deep and cupping and stuff. And no telling if you took water that had been sitting there and tested it, what you would get out of it, but that's long past being able to test. But you wouldn't want to drink it, and my God, it would be higher in iron, of course, every time that you would do a test out of it. At certain times, it would probably be just rust pools, certainly, sitting in it. Anyhow, so this appears at least to be a chunk of something that was sitting here that got moved down here at the time that we're talking about. And one bad apple don't spoil the whole bunch. And our problem is trying to find any evidence. And the flood is the evidence. And you'd expect there to be 3 or 4 craters up here. And that could do it. And you could say, well, 1 or 2 hit here, and later 1 or 2 hit here, and then later 1 more, or whatever the scientists want to come up with. But sure as hell, within about 1100 year period, all that went boop, and all the ice that was down to here went away, and all the water that was in a ponding, the only thing that would be more demeaning would be to call it puddling. Ponds, quite often you can cast a fishing rod across when you're fishing and hit the other bank and pull across and things like that. A pond only gets to a certain point before it calls a lake. I'm not the authority on where that point is, but when we talk about ponding, making Lake Missoula, and Lake Missoula would be the largest lake in the world pretty much, then it has to be like, what? Okay, so things that can associate that. And they tell you that some of these ice raft, including boulders known as glacial erratics. Now, erratics comes from Latin error, like, well, there's this thing, and then how the hell did this rock get here? It comes from error. Like the Willamette meteorite, which eventually sank in the flood waters and settled where they were found by humans. Deep crevices of the meteorite resulted from both its high-speed atmospheric entry and its subsequent weathering. Exposed to the elements for thousands of years, rainwater interacted with mineral triolalite, resulting in a form of sulfuric acid which slowly dissolved portions of the meteorite and resulted in a gradual development of hollows that are visible today, or exaggerated existing hollows that are visible today. And did I go? So this barrier had ponded a huge amount of water at the Lake Missoula right at the time when the meteorite reached the area. The ice barrier became unstable and breached. The resulting flood involved up to a 10 million cubic meters per second of water discharge. With large blocks of ice rafting down the Columbia River and the Willamette Valley at the end of the last ice age 13,000 years ago. Some of these little ice rafts contained boulders bigger than houses and just discharged them along the little higher edge as it started to well and dissipate down, and all the ice kind of melted away and just left it there. This erratic, this error, this what the hell? Well, this isn't a rock. This is something we know came from space. Now, what they have to do is they have to play the innocence run and check into it. And so, this could have been a meteor from 25,000 years ago, and it sat there waiting, and then it just somehow ended up in the glacier, pushed along, and bork, and then it went out. So it can't necessarily be from that exact same time. And then, of course, you'd have to do the thing that they would not do and devil advocate this situation and say something as reasonable as saying what was said before, by saying, and yet it could have happened at the same time and been the reason for the breach itself. Ding. Or it could have been the reason for the pond to be in that area. Ding. It could have been a lot of things, but one thing it is that, oh, it's that ooh part there. Here's one right there. There's one. And this is not like, oh, they found something the size of a basketball that discharged off something that exploded whenever it came in and hit the ice. No, this is huge. Big old chunk. And so they found it on this land, and so this guy made this huge cart thing, and it took him days to pull it, 90 days to pull the thing 3/4 of a mile distance, and he put it on his property. Then he said it was his, and of course the property where it was on was this iron company. Said the statement is he didn't want them people taking it and just melting down, making a beam out of it, something along that line. Anyhow, it all became this big thing. And somebody turned around, William E. Dodge himself turned around and purchased a meteorite for $26,000, which would be about $680,000, close to in 2011, close to $1 million today or closer, after displaying it at Lewis and Clark Centennial Exposition. Here, it's kind of a World's Fair, a little bit kind of thingy, but Centennial American thing. He donated it to the American Museum of Natural History in New York, just gave it to him, said, keep it on display. And so they have, and there it is. There was a ceremony here where they were going to try to give it back to the Indians and stuff, and an agreement was made, like we said before. In response to a student's request, this student's request, Representative John Lim introduced a resolution that would demand that the museum return the meteorite to Oregon, regardless of prior agreements. And the tribe said they were not consulted on this endeavor. They did not support this resolution and were content with the current arrangement with the museum and leave a rock there. So, yeah, I don't even want to talk about that more, and the way that people treat Indian burial grounds and things, and then things that are so old that they can't really claim that they were even maybe the people that were there, because they know that they moved around a lot and things. There is no satiated place for these people. They were semi to majorly nomadic, and they can say they lived on this river forever. But you'd come and dig the sites and you find out, no, you've only been here for about 1,500 years. Where were you before that? Got to be somewhere other than here. We can find some things that are just like your stuff, maybe a little here, but we'd have to dig all this up to tell you where you were. Oh, we were on that river. Says no, or you all of a sudden weren't making any tools till all of a sudden then. I mean, you weren't UG. Oh, no, we weren't UG. Okay, so one or the other, but we don't want to dig up all the Indian mounds. I'm not saying that that's what we should do, guys. I'm saying a lot of these extreme elder sites, reaching into that Clovis area and so on, might ought to be investigated with respect. So they've even made a replica of it in Eugene, Oregon, and so on. Let's look at one more Tomanos meteorite Willamette paper that goes on here. And Tomawanos says that it came from heaven, and I understand now, if you say it backwards, it's Sawanamot. See? The meteorite that survived the mega floods and human folly. And here's a closer look up at it in some of those gouged out areas, and how this is just smooth-ish, and then there's just these giant gouges of taking out of it. But that was supposedly facing up and catching water in it, and it gouged it much more than it was, and where it would hold water at with that acidity effect, it would just eat into it. Then large rain would kind of wash that out, and it would eat and rush and eat and wash out and things like that over time, and made it worse. So rare extraterrestrial rocks like Tomawanas have been kind of fatal attraction for us humans. When European Americans found the pockmarked 15-ton rock more than a century ago, Thomas went through a violent uprooting, a series of lawsuits, a period under armed guard, one of the strangest rock stories I've came across in my years as a geoscientist. But let me start the tale from its beginning, from billion years ago. This rock came from out of a star dying from years ago, like we're saying, made of, most metal meteorites are made of iron and about 8% nickel mixed in. These iron and nickel atoms were formed in the core of large stars that ended their lives in supernova explosions. Massive explosions splattered out in space were products of nuclear fusion and raw elements that ended up in a nebula or cloud of dust clouds. Eventually, these elements were forced together by gravity, forming the earliest planet-like orbs and protoplanets of our current solar system. Some 4.5 billion years ago, Tomanos was one of the core of these protoplanets, or the sun, where heavier metals like iron and nickel accumulate. So in other words, we understand that we haven't been here as long as the universe has, but before we were here, there was another forming before it. Now, they can be primordial element type things that happen, and then they accumulate, create this iron and explode. And they believe that is what creates all of these other elements that accumulate in planets, become the whole periodic table itself, and have the ability to be all the elements that we see to this day. Sometime after that, this protoplanet must have collided with another planetary body, sending this meteorite and an unknowable number of other chunks back out into space. Now, this could have happened from all of that, but it actually could have been in that planet that makes up the asteroid belt and the core of it, and a splayed out chunk of it that somehow got knocked loose, pulled around by Jupiter, and then slung back into us too. Subsequent impacts over billions of years eventually pushed Tomanos' orbit across that of Earth, a result of this cosmic billiards game. The Tomanos meteorite entered the Earth's atmosphere around 17,000 years ago and landed in an ice cap in Canada. I'm not sure how they exactly get this number. Over the following decades, flowing ice started transporting Tomanos southwards towards a glacier in the Fork River of Montana in what is now United States. So the glacier carried in the glacier, This glacier created a 2,000-foot high ice dam across the river, impounding the enormous Lake Missoula upstream. The dam crumbled when Tomanos was entering it, or was nearing it, releasing one of the largest floods ever documented, the Missoula floods, which shaped the scablands of Washington state with the power of several thousand Niagara Falls. Some say it was even larger. Trapped ice and rafted down a river by the flood, Tomanos crossed modern-day Idaho, Washington, and Oregon along the swollen Columbia River at speeds sometimes faster than 40 miles per hour, about 60, they say, an average, according to simulations by modern geologists. While floating near what's now the city of Portland, the meteorite's ice case broke apart and Tomanos sank to the river bottom. So it was such a deep river that it was still just floating in an ice cube, and as the ice cube melted, then flink, out fell the nickel, dime, quarter, chunk of rock, and it stayed there. That's a weird visual, but could have been carried down and then deposited in still ice that just caught up against the edge in a bumpish area and then rolled down to the spot that it is. There's 101 scenarios. One thing's for sure, we can't be totally sure, right? But it is one of hundreds of other erratic rocks made of elements that do not match the local geology, and that may have been found along the Columbus River, and all souvenirs from the cataclysmic Missoula floods, but none is as rare as this Tomanos meteorite, for it shows you something very different. And I wonder how long. Glacial Lake Missoula trailer. I'm going to watch that as a separate here in a minute. Geological evidence of the Missoula flood includes prairie ripple marks layered in silt, and so when the sun comes over, you can see where it etched through it, and as it went down, it was still rushing with all the force that it caused this effect running down. And if it did it in here, it did it there, and it did it all the way through this valley and on down and way on down until it finds the ocean eventually. So they talk about having sued for it and everything else. I think there's not much in there that tells you it's just all that runs the case of doing it. So here's the displayed meteorite there. It's not really that huge. Could be just a chunk, one of many. For the other ones, might have sat there and somehow when it let loose got ground into the ground and then covered over by all the crap from upstream coming and pushing down. And some of these little bumps that look like they're little wave marks that are really not little but 40-50 foot tall might contain a bunch of these. Now, no one's saying to waste billions on going and digging up all those bumps or anything like that, but just saying it's a possibility. So it's still on exhibit. They talk about the Confederate tribes and didn't want it back, even though they flew this lawsuit. It's kind of like the American people on behalf did all this thing, and they were like, "We don't want your rock, man." Previously, scientists have followed Lyell's principle of uniformitarianism, which held that Earth's landscape was sculpted by regular natural processes on slow, easy-listening music, distributed evenly over a long time on slow, rainy days. Normal floods fit into this theory, but the notion of this kabam doesn't fit into it. Yet catastrophic events like Lake Missoula floods were somewhat heretic to their idea. And the fact that there's a series of them here that are all somewhat interconnected into this glacier thing gives you an idea that, no, man, there was something big that happened all through here. And this is just one sign on the planet of big things that happen like that. And localized floods